Hello everyone, my name is Weilun Li. My project is about human perception based on image filtering and hybrid images. First, I'd like to introduce the hybrid image. The Marilyn Monroe Albert Einstein illusion, an amazing visual illusion image, is presented in front of us. Looking at this image up close, you can see Albert Einstein. Whereas when you move away from this picture and observe it, you can see Marilyn Monroe. This shows that the precising of objects by the human perception system varies with the change of viewing distance. So it is very important to understand how the picture is produced, which can give us a deeper understanding of the working principle of the human perception system. We can clearly see that this illusion image is composed of two different pictures through an image processing. This is the so-called hybrid image. So in this project, the specific image processing process, including the selection and design of image filtering, will be shown. Regarding the study of this phenomenon of observational difference, we can start with the process of making this image. The low frequency is the low change of color, that is, the slow change of grayscale, which means that it is a continuous gradual change of an area. And this part is the low frequency. For an image, excluding the high frequency is the low frequency. The content within the edge is low frequency, and the content within the edge is most of information of the image. So the general outline and contour of the image, which is approximate information of the image. So how can we get out the low frequency signals of a picture? We can use low-pass filters to achieve the goal. The figure shows a very simple low-pass filter LF. An original image I1 can be filtered by this low-pass filter to remove all the high-frequency signals, leaving only the low-frequency signals. The specific performance of the image is that only the general outline of the image is left, and the whole becomes very blurred, and the details on the image are basically indistinguishable. This newly obtained image can be expressed as low is equal to I1 times LF. Of course, we can also use Gaussian filter to do the same job. Gaussian function is a normal distribution of the arc curve. The center of the value of the highest, and the more to the size of its value is smaller. There are 3 by 3, a total of 9 pixel points, with the middle point at the origin, brought into the formula to get the white metric. Assuming that there are now 9 pixel points also arranged in 3 by 3. Each point is multiplied with its own corresponding white and added together to get the value of the Gaussian blur of the center point. Repeating this process for all points, the image after Gaussian blur is obtained. High frequency is when the frequency changes quickly, when there is a large difference in grayscale between adjacent areas. That is changing fast. In an image, the edge areas of an image and the background are usually significantly different, which means changing that edge there. The grayscale changes quickly. The area that changes with high frequency, therefore, the gray value of the edge of the image changes quickly. which correspond to a high frequency. So high frequency display image F. The details of the image are also in the area where the green value changes rapidly, and it is because of the rapid change of green value that the details appear. In this experiment, we can use Gaussian blur only to achieve high-pass filtering precise. A new image I2 is passed through Gaussian blur G to obtain the low-pass filtered image. And then the original image I2 is subtracted from the precise image, obtain the image with only high-frequency signal remaining. And the final image can be expressed as high is equal to I2 minus I2 times G. So there's no need to design an additional high-pass filter. The hybrid image processing is not complicated. A hybrid image can generate by superimposing one image, which is processed by high-pass filtering, and only high-frequency signals like details are left, and another blurred image, which is filtered by low frequency, and only appearance contour are left. This can be expressed as HV is equal to I1 times G plus I2 minus I2 times G. The final result is as shown before. The left image is the high frequency only image. The right image is the low frequency image after Gaussian blurring. And the bottom image is the final hybrid image. This part is my main function, which shows the precise of Gaussian blur and the high frequency processing, as well as the final hybrid image. I convolve each dimension of the image with the Gaussian filter respectively. It is worth noting that the standard cutoff frequency for Gaussian blur is 7. But this is not suitable for every image. I finally choose 14 as the cutoff frequency through several experiments to obtain a relatively good result. This part is the image display code. I set a total of 8 images to display. The magnification of each image is 0.8. The final effect as shown above can reflect the effect similar to the human observation of the image of the increasing distance. The purpose of understanding the principle of hybrid image generation is to understand how the human visual system works. In this experiment, from the final hybrid image obtained, we can clearly see that when the picture is larger, it is the high frequency part of the picture that is shown as the main body in humans' eyes. While when the picture is smaller, the low frequency part of the picture is more obvious in human vision. This means that the working of human visual system changes at the distance between the observation target and the human changes. When humans look at a distance, most of visual signal captured is low frequency information, while when they come closer to observe, high frequency information has occupied most of the visual signal. However, this experiment is now designed to make the image roughly aligned, which will result in poor blending out when using two images with large shape difference. If the contour of two images are not very clear, it will also lead to a poor blending result. Also, since the cutoff frequency needs to be manually adjusted, it is difficult to produce optimal results without multiple trials, which greatly increase the time. Further, the basic principle of filtering the signal through a filter, like hybrid image, may also be used for blending process for video. For example, ideally, two videos are combined into one video, similar to hybrid image, where the first video is seen at a distance, while the other video is seen at a close distance, which may also be extremely helpful for information encryption processing. Thank you for your watching.